Hi guys, welcome to today's recording. Now I'm going to go through the NCEA Level 3 Organics topic very quickly. I'm aiming to get this done in 10 minutes. Just to go through the important things of the unit, and because I'm not going to go into too much detail with, let's say for example, flowchart. I'm not going to do explain how the reactions work with the flowchart, etc. Probably do that later down the track before the end of year school exams or the NCEA examinations. But just the key points for this topic. Okay, so I'll try to keep this short. Now with the organics, so the first thing that you need to do is naming and drawing. And this is something that's very, very basic. Like if you can't at this, if you have an assessment like my class later down this week, and if you still can't differentiate between an amine and amide and an aldehyde and a ketone, for example, then the chances of you passing is very, very slim. You need to at least identify the functional groups and be able to write down the names, and this is normally achieved for NCEA Level 1, NCEA Level 3. For topic tests, it might give you a merit, but you should know that's quite inflated. Normally, it's only achieved. Okay. Now, after that, you would have done one thing that you need to do is your isomers. Now, you would have done your structural isomers, and then you would have done cis and trans isomers or geometric isomers, and then you would have done optical isomers this year. Okay, now as a year 13, you don't need to worry about that one. I can tell you that they never examined us because the emphasis is on optical isomer and structural isomer. And I've done this with my classes. I think if you look at the NCEA exams for the past couple of years, they love giving out questions that they give you the molecular formula, like say for example they give you C5H H10 H10O. Let me just see if this works. They give you something like this: CH3, CH3, CH2, something like that. So they give you something like this, C5H10O, and they give you some conditions, and they'll go, oh, this particular one structural isomer of this can react with Toland's reagent. Or you can say one of this doesn't react with Toland's reagent. You can draw a straight chain, branch chain, blah, blah, blah. They give you a lot of the conditions. So they link the structural isomer with a lot of other things like distinguishing tests, with some chemical physical properties. So you really need to know your structural isomers, because if you can't draw the structure, you're not going to be able to do anything. Okay, so this is like the structural isomers on its own. This is probably not that hard, but then they link it with something else. So I highly recommend you, if you are preparing for like an assessment, I do recommend you to have a look at my previous year's videos. I think I would have done one of these in I think it was 2019 or 2018, I can't remember, but that would have been covered, and I strongly recommend you to have a look at that in more detail. Now with the optical isomer, this is something new this year, so you need to identify your chiral carbon. So this chiral carbon must be bonding to 4 different groups. It doesn't have to be specifically 4 different elements, but they need to be different groups. Like say for example, OH, H, CH3, CH2, CH3. So this is 4 different groups. This is your chiral carbon, and then you can form. And I always tell my class that just think about your hands. Your hands are perfectly good examples of optical isomers. They are exactly the same, and they are non-superimposable, which means if you put one over the other, they can't overlap completely, yet they are exactly the same. So they are mirror images, and the only way to differentiate them is to shine a plane of polarized light through that structure, through the molecule, through the liquid, and then one particular isomer will rotate it one way clockwise, and the other one will do anti-clockwise. Okay, so that's kind of like a merit-ish type of question for the optical isomers. Being able to explain, being able to draw them, being able to explain how you differentiate them. That's kind of like a merit question. All right, and then just with the reaction, now the rest is all reactions if you think about it. So with the year, this is year 12, but the thing is you need to know this from year 12 all the way to year 13. So you need both years. So you need to be able to go all the way from alkene to an alcohol, and then from your primary alcohol to an aldehyde, and then from your aldehyde to a carboxylic acid, then carboxylic acid to an ester. Then you can also do hydrolysis back to the carboxylic acid. Your carboxylic acid can turn into acyl chloride or acid chloride, doesn't matter which one, and then that can turn into an ester, and then you can turn this into an amide, and then you can also do hydrolysis back to the acid. Then you can do the acyl chloride. But then this section is year 12, and they can do more, like they can turn the alkane into a haloalkane, for example. So you still need to know your major minor products from year 12, and this is why, particularly at my school, I think most schools do, we have prerequisite. If you sucked in organic in year 12, there's a very high chance that you will suck in year 13, because half of it is from year 12. So if you didn't do so well in year 12, that means you really want to pass organic chemistry, you really need to put in somewhere else and into some studying. Go watch my videos, maybe those will help. Maybe start with the year 12s first. But so those are your major minor products. They can still ask you those from year 12, so that's your year 12 section. And then so if you think about the reactions, you have addition reaction, you have substitution reaction, you have the elimination reaction, you have oxidation reaction. This year you also learned reduction reaction, you learned and this year you also learned hydrolysis, and then you learned condensation reactions. Okay, so those are the different and then you have your neutralization reaction as well. So those are your the different types of reactions. You need to know what reagents you need to use, and please, even though I've drawn it this way, I wouldn't recommend you to learn it like this. I would like you to start with and I always do this, even though with the year 13 with the year 12 videos I say it's the same thing, because this is by far the basic example that you could do. Can you turn this alkene, you're starting with the alkene, can you turn that all the way into, like, say, an acyl chloride? Can you figure out any major minor products along the way? Can you do that, with the help of your notes, open book? Can you draw a flow chart? Start with butane. Don't memorize, alcohol to aldehyde. So primary alcohol to aldehyde. Yes, you can remember that, but if I give you an alcohol, can you actually turn that into an aldehyde? So that is the question you need to ask yourself, because from experience, a lot of people that just memorize that and think they're okay actually won't be able to survive a test, because we don't give you the format of the flowchart in the one that I've drawn on the left. You get given, just go through some past exam papers, you'll see how the flowcharts are drawn. It's literally a flowchart, and you need to know what turns into what is the reagents required, what is the type of reaction. There's only one correct answer, so you can't, like I always say, you can't BS your way out of it, because I've said this many times to my class. I double majored in biology. Sometimes if I get confused with the bio questions, I just talk about things I do know, and sometimes I get given marks for them. But for chem, there's only one answer. You can't write anything else. Anything else would not be accepted. Okay, now the big part for this section is condensation polymerization. Now I just did a video yesterday, so you can go watch that. So this is the polymerization and the hydrolysis. This is guaranteed an excellence question, and then you have the distinguishing test, which is again like a guaranteed excellence question. But the thing with these is that they can mix and match, especially year 13. Year 12 they're quite limited, but with year 13, like, I love doing the year 13 organic paper, because it's not being nerdy or anything, but it's like solving a puzzle, and they have so many ways to change how the questions are worded, and this it really shows how well the examiners design the questions. And some questions I just love doing them, because it actually gets you thinking. So the distinguishing test is something like, to distinguish the alkanes use bromine water. To distinguish the aldehyde, use Toland's reagent, or Benedict solution, or a failing solution, and then to distinguish acyl chloride, you simply use water, and you can also use water depending on the solubility. How many layers would you see due to their solubility? You can also do carbonate, like say do carbonate, anything carbonate, sodium carbonate, potassium carbonate, doesn't matter what it does to differentiate the carboxylic acid. You can do litmus paper, and if your school taught you Lucas reagent to distinguish the primary secondary alcohol. Primary doesn't react with this, secondary turns cloudy in a few minutes, and tertiary turns cloudy very quickly. Or you can stick to the traditional MnO4 minus, H plus, or Cr2O72 minus, but this is where people get it wrong, okay? Because if you oxidize a primary or secondary alcohol with those two solutions that I just wrote, you won't be able to tell which one's which, because they will both react, and you can't tell which one's aldehyde, which one's carboxylic acid. And this is where people go, oh, I'll just keep reacting them, and the one that turns into the carboxylic acid, I can just use litmus paper. But here it is, my friend. Well, look at the condition. Both of these solutions have some acid from the reagent that we use to make this reaction work. So regardless of which one you will use, which one makes carboxylic acid, if you use litmus paper at the end, they will both turn red because of the acid that you have put in at the beginning of the reaction, not because of the acid that you have produced. So many times I've seen that mistake. It just shows that you don't really understand what you're trying to talk about. You're not paying attention to the condition, and it's not just one or two people. It's like dozens every single year. At my school, every single year. So it doesn't matter how many times you tell them, they still do it. So that's that. All right, and then the last thing that you need to do is the technique, which is mainly reflux and distillation. So you need to understand how each works. This is kind of like a mirror, and then use of acid, concentrated acid. What do you use that for? The use of anhydrous stuff. I think it was sodium, so I can't remember exactly which one. There are quite a few. This is kind of like a mirrored-ish type of question. So you need to know that reflux is more of a what do you call it? Like you're trying to keep everything in the container, and then you heat it up as much as you can. You're really increasing the rates of reaction, and they will react as really quickly. Whereas distillation, you're trying to make the aldehyde. You're trying to from alcohol to aldehyde to carboxylic acid. The moment any aldehyde is produced, they will get extracted. They will be distilled. They will evaporate, come out the other side, because they have a lower boiling point, because they don't have hydrogen bonding. And then use of the concentrated acid is to use as a catalyst, also as a dehydration unit, to get rid of any excess water. And also the same thing with any anhydrous. If you see the word anhydrous, anything, doesn't matter what they write under afterwards, anhydrous just means no water. And what is the purpose? To take away water, to remove any excess water from the solution. Okay, so that's pretty much it. That's the important section, all the important things you need to know for organics for NCEA level 3. Obviously, this is, I'm counting on you to visit some of my other videos to go through some of the questions in more detail, but these are the important concepts that you will need to know for like a topic test or like a school exams, just like a last minute check to see if you got everything. So hopefully this has helped, and yeah, I'll see you guys next time. Bye bye.